And then we're going to have a panel discussion. I'll call our panelists up individually here soon. So we'll start again with our esteemed professor, Jorge Riera.
Thank you. I can see that the right ventricle is full of blood. But we have here the left ventricle empty. So the podium is here, so I feel a little bit strange. I'm talking to empty seat here, so you can just come and sit in this front seat. That would be great. Now we have blood flowing in the other. Okay, so these have been amazing, and I'm sorry that I missed the morning session. There was a commitment, but I remember last year when we have this celebration. If my calculations are correct, we were around 60 to 80 persons in a small fraction of this room here, and this year I think we are more than 200 people. So if we make a projection for next year, we will need a bigger university, I think, or something like that. So in last year event, I mentioned initiative in the department to stimulate cardiovascular research, and I want to start by reporting on those projections, and also now make new projections next year. And everything is moving in an amazing speed. So we plan to have new core facilities that help or provide some support to cardiovascular research. And within this core facility, we mentioned that we will have a histology facility, core section. So we already have core instrument. We have a lab technician, a lab manager for that core facility, that everything is going to be on a website, that you can reserve the use of the machine. It's an 80K cryostat, $80,000 cryostat, and a 130 microscope system for cell classification and imaging. And also we promised that we will have an area or facility for acute slice preparation for confocal imaging and PCR analysis, and we finished that. Now we are in the construction phase. We purchased all equipment. Now we are just installing tables and cabinet, and I will be ready by the end of spring. And it's again with a PCR machine, couple of vibratome for sectioning, and we have water baths and other instruments. And it's in an order of around $60,000. And we purchased a Raman microscope, a part of the collaboration between mechanical, and that's another thing that I want to make, a clear statement here. This is showing for the first time, or at least strong interdisciplinary components. So we have the chair of material mechanical engineering, Dr. Agawar there, and representation from SelfMed, and also we have activity organized by PathOps, so two national recognized engineering research centers that are now linked to this event. And we have other external participants, researchers, and members from different organizations. So we purchased a Raman microscope that established a direct connection between mechanical and biomedical, material mechanical engineering department and biomedical engineering department. And actually we have a new recruited faculty that will make that connection to that. So we just going to renovate the cell culture core. I got a quote in front of me of around $80,000, and we start already purchasing the equipment. So everything that we promised in that meeting last year, we are already set to start working. So what is next? What am I going to be talking next year is we are very ambitious. We want to create a triangle of research connection between Baptist Cardiovascular Research Center, the College of Medicine at FIU, and the Biomedical Engineering and Material Mechanical Engineering Department at Florida International. So we know that there's a lot of doors that we have to knock this to happen, and a lot of people that we have to convince. But thanks to all our external collaborators and in particular to the Florida Heart Research Foundation that have been our guide, been the engine that promote this initiative. So we hope that we will have that in a very advanced stage next year. We also want to have another set of equipment. We are looking at more translational equipment that allows our research to be put in a stage of clinical application or close to that. So we are looking at an ultrasound equipment for rodents and possibly a micro PET equipment that also for rodents. So we also have an ambition to start looking at organoid development, and that's something that we are now already. So I can say that probably next year I will have some more good news about this. But enjoy this celebration. This is a celebration. By the way, I looked just right now how many universities in the United States have a heart research day or cardiovascular research day. And guess what? There's not many. I just found two. University of Kentucky and Washington University San Luis. So we are the third one doing that kind of celebration. So with that, I just want to thank all the participants and invite you to listen in our next section. There's a panel discussion, and we will have also the awards. So thank you very much.
I'll ask Dr. Riera to stay and Dr. Dickerson to maybe join us up here, and we'll give awards for our poster symposium. So for those of you who don't know, we had our grad students, undergrads, postdocs present posters earlier, and it was judged. And we scored the top 3, and we have a little prize for each of you. So the third place poster was given by Paul Stanky. I know the other 2 are here. This is not rigged, but second place, Mohammed Shiver. And our top rated poster was Sophie Ashbrook. Congratulations to our poster winners. It's a big day for Sophie. She also got her first paper published today. All right, so we'll move on to our panel discussion now. So make sure I get the names correct. So we have some esteemed panelists who will come up here, and this is open to the audience. So before I even announce them, what I want you to do, whether even if you're a high schooler, what we want is this is a time for you to ask all the questions you might have about cardiovascular health, cardiovascular research, cardiovascular medicine, anything that you want to know. These folks have the answers. All right. So first, I would like to call Dr. Eric Griggs, who is an MD focused on community health. Next, Ms. Claudia Correa, who is a registered dietitian and licensed nutritionist. Then we have Dr. Lydia Koss, who is the Associate Dean of the University Graduate School and Associate VP of Research at FIU and Professor of Biology. Next, we have my co-host, co-master of ceremonies today, Dr. Daryl Dickerson, Assistant Professor of Materials and Mechanical Engineering. And last but certainly not least, Dr. Calvin Mackey from STEM NOLA. Just so we get to know each of you, maybe just one or two sentences very briefly about who you are and where you're from, so kind of the audience kind of knows a bit more about you before we start.
Okay, my name is Dr. Eric Griggs. I'm the ooh-ah guy. Originally from North Carolina, I live in New Orleans. I am the Assistant Vice President of Community Health Affairs for Access Health Louisiana. What is that? It's a system of primary care clinics. We have 40 clinics. I'm responsible for 50,000 patients. I'm also the TV doctor for Fox 8 in New Orleans for the last 10 years. About 1 million to 2 million people every day.
Good afternoon, everyone. I'm Claudia Correa. I'm a registered dietitian and licensed nutritionist, and I've been working in the field of prevention for many, many years, over 13 years, and today I'm here with my family from Florida Heart Research.
Hi everybody, I'm Lydia Cos. I'm originally from Brazil. I came to the US for graduate studies. I went to UC Berkeley for my PhD, then I went to NIH, National Institutes of Health in Maryland, and then I came down here, became an assistant professor, associate professor, and now I am the associate dean of the university. I have a lot of titles. Associate dean of the University Graduate School. What that means is I oversee all the graduate students at FIU, all the master students, all the PhD students, make sure everybody is happy, everybody gets their degree, and everybody gets a job after. At least that's what I think I'm doing. And I am the Associate Vice President in the Office of Research and Economic Development. So this is the office of FIU that takes care of all of the sponsored research projects. So everybody, Dr. Hutchison, Taro, everybody who brings in funds to do their research, to maintain their labs, our office oversees those projects. And I'm also a cardiovascular researcher.
All right, I'm Dr. Darrell Dickerson. I'm an assistant professor in mechanical and materials engineering, and also the Education and Workforce Development Director for the Settlement Engineering Research Center. So part of what I do with my research is to understand how complex tissues work. So I want to understand the forces that they experience, understand, how do we characterize those tissues, and then use that to create biomaterials so that when those tissues are injured, we can regenerate them. We can help cells to rebuild what has been lost. And so that's a major portion of my research, really focused in cardiovascular right now. So, for the high school students who are here, you were working with the hearts before, so I'm working on how do we fix the heart with new biomaterials and influencing cells to do so.
Again, I'm Dr. Calvin Mackey, and I told you a little bit about me, but when I did not tell you that, I used to be a professor of engineering for 12 years at Tulane University. I got my PhD from Georgia Tech in fluid mechanics. And even though I say I hate biology and I hate all that stuff, and I do, my PhD was in fluid mechanics, and then once I got to Tulane and became a professor, I began to partner with people doing research with the bioengineering and biomedical people on stenosis, modeling collapsible tubes to show how plaque builds up in a heart. So even though I studied fluid mechanics, I went all the way back around to partnering with the bio people in the end.
I am one of those biologists that he doesn't like.
So I'd like to, my goal here is to talk as little as possible, but I have plenty of questions for these folks, but I can talk to them offline, so I want y'all to ask the questions. What questions do we have?
Don't make us. So I left off the fact that I'm a professor. We'll call on you.
Hi, I'm Tina, PhD student here. Did you originally, I know you weren't interested in biology or art, but did you know that you wanted to go into cardiovascular related field, or did it just hit you out of nowhere?
So I'll start. How many high schoolers we have in there? Any high schoolers? Yeah, so you'll appreciate this. I was 16 and I was 5'2" until I was 16, and my voice hasn't changed. I don't think it ever did. That's not funny. No, it is. I went to a program called the Explorer program at my church, and they had the legal explorers over here because I saw lawyers, and they had, it dates myself, they had convertible Volkswagen Bugs and pretty girls. So I wanted to be a lawyer, and I went to the church, and all the legal people they were my friends, and they were all like 6 feet tall and deep voices. And I looked in the medical explorers, and it was all women, all girls. So I'm like, man, I got a shot. Followed that path and ended up getting in a high school program where this is when the HIV epidemic had just come out. It was 1986, and it was the end of a hall. They were in hazmat suits. I was following a Dr. James Peacock. It was myself and 4 other young ladies. And they went to the isolation room. He went in. He didn't put on a hazmat suit. He washed his hand, and he sat on the bed with this guy that was 36 years old. He was weighed a little bit less than me, which isn't hard these days. Sitting on the bed, and his wife and his daughter were sitting in the bay window. Long of the short, he told that guy, he grabbed him by the hand, and I heard him say that, I don't know what this is, but I know this is not something that stops me from being your doctor. And I think someone pushed me in the room, and the onion started coming out, because by the end of it, all of us were hugging on the bed and crying. I'm like, so I want to go into medicine, and that's kind of where this all started.
So my story is, I'm from Colombia. So as many of you might know, and I know there are a lot of people here from Colombia, right? Somebody? I know I did talk to a few. So there you go. Well, my story is when I was 13, my dad had a stroke. And at that age, I didn't have any clue of what was really happening. But I remember him going to therapy, to the hospital. So he had to go to therapy. I think in the beginning it was like once or twice a week. And then all of a sudden at home, we were like, we're not gonna eat that much red meat anymore. Like, oh, okay, I guess we're gonna eat more fish, fine, that's okay. But then I started looking up, I had a really good biology teacher. I love biology and anatomy. So I started asking questions, like why did this happen to my dad? How can we help? What else do we need to do at home? And since then, I really started becoming more aware of what we were eating, how much, or why are we doing this now, like eating more fish. And that really started my conversation with teachers about how the body functions. And since then, that was my goal. Honestly, I met the physical therapist that was working with my dad, and that was my first goal, to become a physical therapist. So, and that's what I started doing in college in Colombia. But then I ended up coming to the States, and I worked in a PT department in a hospital in New York, just doing volunteer work, and I realized most of the patients that were coming were people that had a heart attack or a stroke. And I said, well, but how can we prevent this from happening? I ended up taking a nutrition class, and I loved my teacher. She was amazing, and she really made me think about prevention. So then I switched to nutrition, and that's how I ended up becoming a registered dietitian. That's my latest.
I think you know my story. No. Let's see how I'm going to answer that. How do you get to work on cardiovascular research? I actually wanted to be a dancer, and I wasn't that great. And I really wanted to be able to be creative. And as I said, I'm not that great of a dancer. Maybe I can do research. And my interest was in neurobiology. So my degree is actually in neurobiology, the study of the brain. My PhD degree is in neurobiology. And from there, I ended up studying pigment cells. And you're going to say, oh my God, why is she a neurobiologist studying pigment cells? And pigment cells are those cells that they're called melanocytes that make the pigment that gives the color to your skin, to your hair. And I'm not going to explain to you how a neurobiologist ends up studying melanocytes. But, and that's sort of how I built my lab, trying to understand how do cells become pigment cells. And a graduate student in the lab happened to be looking at some heart tissue for a different reason, and found melanocytes in the heart, pigment cells in the heart, specifically in mouse hearts, because I'm a mouse molecular geneticist. And that's how I got involved in cardiovascular research. And Dr. Agarwal, all the way back there, was one of the first persons that I worked with, because we said, oh my God, what are these pigment cells doing in the heart? Specifically, they're found in the heart valves. And Dr. Agarwal, we thought together that they might have something to do with regulating the mechanical behavior of the heart valves, because they're full of pigment and they produce stuff. And that's how we ended up. And then Dr. Hutchison came along with a heart valve expert, and now we work together.
So when I did my PhD, my focus in my PhD was actually in orthopedics. So very interested in the connection of bone to the soft connective tissues in the body. So that's ligaments and tendons and cartilage. And so that was the focus of my work for a very long time. And actually used what we developed as a biomaterial during my PhD to start a company and eventually get that commercialized. And so that led me down more of a translational pathway overall. So the work that I do, I'm very interested in making sure that it has relevance to human health in a translational way so that it eventually gets to people. I mean, that's critically important to me. The work that I do eventually has to get to people because it doesn't feel like it's good work otherwise for me. So I didn't start anything cardiac related actually until I got here at FIU. So I had 10 years of work in the startup company focused on that translation. And then when I got here, it was an opportunity to look at new options for what we learned from the complex tissues of the interface between hard tissue and soft tissue and translating that to other complex tissues. And with the heart, there are a lot of complexities there, as you can imagine. It has a very important job. It's working consistently, constantly. There are interfaces there between harder tissues and softer tissues, not quite hard and soft, but harder and softer. But also interested in sort of the electrical, mechanical connections within the heart. And so that's a complexity I really wanted to study and translate what I learned from the orthopedic interfaces to heart tissue.
Hi, I'm Daniel, PhD student. This is a question for, I guess, all of you, and then Dr. Hutchison, you can also jump in if you would like. In your experiences as clinicians, researchers, dietitians, how has cardiovascular health and the way we attack it changed in maybe recent decades based on technology advancements or new knowledge that comes onto the field or new techniques to treat patients? How has that evolved, and where do you see it going in the future?
Yes.
I'd like to answer it, but I think it best starts with food.
Right. And that's really where I've seen most of the, on the prevention side of it. So I talk to many people on a weekly basis, and in the beginning, when you get out of school, you come out with these ideas and the 1,200 calorie diet, and you give them this and that, and low fat and saturated fat, like very precise, but at the end, what I believe that has been more successful, like for me personally as a dietitian, is getting to know the patient and start really getting to know them and their families. Because if you start talking to them about a diet and they need to change from the red meat that they're eating every day to maybe the fish, and you don't ask the questions, can they afford eating more fish? Are the family gonna be okay with this change in diet? Or even, are they even willing to change because maybe they did get a little scared, right? But they're not even buying what you're trying to teach them. So it all starts there, developing that relationship, but also involving the family, and I think that's where we get more successful stories. Food, I love food, right? For someone culturally, like for Latin people, we like our rice, we might like our chicken seasoned in certain ways, we like to eat our tostones or a little bit of fried this. Vegetables are like the last thing maybe on that plate. And so instead of coaching people on, let's change it all at once. Let's start with baby steps. Let's start with, let's reduce the portion. Let's do this. If you think about the food guide pyramid years ago, was really a pyramid, and that was the guide to help people eat better, or at least for them to have a picture of what eating healthy it was. But that has changed, right? Have you seen the new guidelines for eating? Now it's not a pyramid, it's actually a plate. Right? And that actually brought up a lot of change in the communities, in the clinics, in the hospitals, because now we're not talking about eat a lot of this and a little bit of that, but more like include more of this instead of just avoid all of that. Just let's eat a little bit more of fiber. Why the vegetables? Maybe decrease a little bit the portion on this. And I think nutrition education has changed for the better. And I think with cardiovascular disease, we know the risk factors for cardiovascular disease. Can anyone name a risk factor for heart disease? Diabetes, smoking, yes, hypertension, blood pressure. That's another, right, risk factor. There is one very important. Obesity, yes, right? Being too sedentary, right? If we don't move enough. So talking about all of these risk factors, maybe my client, my patient is not willing to change at all, but they tell me, okay, I'm willing to start walking every day. That's where we start. I'm not talking about food with them, we're talking about how that person is gonna achieve their goal, which is walking every day for 20, 25 minutes. So coaching, and I know I'm a certified wellness coach as well, but what that program, that certification taught me is more about that one-on-one aspect of nutrition counseling. And that's where I can make the biggest impact, honestly. The information is out there. Any patient can go online, Google this and that, what's a healthy diet, what is the Mediterranean diet, but if they don't have someone to guide them through, listen to them, then all of that information just stays there in their brain, but there is no action. So I think that's one of the biggest improvements.
Did you want to add to that? Or? I was actually going to go to Dr. Mackey on. Yeah, go ahead.
About the wearable technology.
Well, and that's what I was going to talk about. It's the evolution of the technology. If you think about, I mean, back when I started, the doctor was at the top, the clinician. No one told that it was all the PhDs that were teaching us in med school about it. There's more accountability to put the power in your hands as a patient. Wearable technology, not only giving you the watts, but telling you what atrial fibrillation is, telling you the parts of the heart, teaching that you can't outwork a bad diet. What exactly is a bad diet? You know, the fads and trends over the years have been, oh, we're gonna go low sugar, first we're gonna take all the fat out. Let's go low fat. Well, what goes with the fat? The flavor. So what do? You add sugar, you add salt. And teaching people and having experts acknowledging in medical education, there's more of an emphasis now on a holistic approach because we have to be held accountable. I can't just tell you go take a pill. What can I eat? My nutrition education was maybe a class, maybe, as opposed to a whole component to someone's whole life. But the wearable technologies, as they're evolving, and the more we're able to give the information to the people that are going to use it, you're 100% the expert on you. So you need to know what this stuff means, and then come to the experts to interpret and move forward. So it's that accountability, and there's a lot to come.
Can we stay on that theme? Because I kind of want to go to Dr. Mackey for 1 second on this, because I want to know what you've learned, developing this program that is trying to educate people, right? And trying to teach about physiology, teach about disease, or whatever, approaches that work and don't work that we might be able to learn as researchers, as MDs, as nutritionists.
Thanks for that question. That's what I wanted Dr. Griggs to answer, because I've learned so much by working with him to try to come up with a way to infuse the knowledge into the community. So on a heart day like this, we would have, when the kids come in, we would have healthy eating, health bars, everything. Because like sometimes at our events we had pizza, like we can't have a heart day and serve bad food. So I mean, from when we introduced to the community that is food, that is movement, that's why we had the kids exercising and listening to their heart, to try to get them to see. Dr. Griggs didn't tell you his mantra. His mantra is get fit, get checked, get moving. That's what he brings to the community. So we try to show the community, just common everyday people, every aspect of the heart, so they can know it's just more than just exercising, it's more than just food, but it's a whole lifestyle change. And every one of those activities, from if we, for example, if we had the 3D printer, we would be printing a heart to explain to the community that, hey, you know, there's now mechanical ways that they can take care of your heart. We have the virtual reality so they can literally stand into the circulatory system and look at stenosis and plaque and understand that when you eat this food, this is what happens to your arteries. And then one thing that we do with the mechanical heart that we've been working with the American Heart Association is that when the young people build those mechanical hearts and we explain to them about a healthy heart, they'll go home and tell their parents why they can't eat the things that they've been eating, because they've learned about what a healthy heart is and why it's necessary. So I learned a lot of that by trying to put that together for the community. And I think sometimes as researchers and as academics, we miss that component because we're so focused on the academics that somehow we don't think about the lens through the community and everyday common person.
You want to add to that? Oh, yeah.
On those academics that don't think about the community. I think for me, Daniel, you know that the availability of data, like you just can click on some publicly available data set. When I started looking at, so I'm a geneticist, right? And you brought up that genetics is a risk factor for cardiovascular disease. We had to go to human patients and spend years. I spent my first 3 years of my postdoc after I finished my PhD trying to figure out which gene was mutated in a particular pigmentary disorder. 3 years doing a whole series of, and this is in mice where I had to cross the mice and do this and sequence by myself. Nobody does that anymore. With sequencing the genome, we had to go in and do it. And now you have mouse genome, human genome, every possible genome. And all you have to do is click. So then it can go in and look at data sets. And we want to find out, we found these genes and how are they related? And do they have anything to do with heart development? And so just this availability of data and the availability of sort of, and now with machine learning and artificial intelligence, the speed at which you can do things, it's actually scary to me. Probably not to you, but scary to me. Because, anyway, it's mind-blowing.
Yeah, go ahead, yes.
So you guys all have like really inspiring stories of where you came from and where you are now. How have you persevered through all of the different things that you've had to go through?
Yeah, the question was, so very inspiring stories of how they got to where they are, but how have they persevered through maybe challenges and tribulations to get to where they are and stay focused?
I'm the one with the mic. Like now, right? No. I grew up being the kid that wasn't really understood, or I was supported but not supported. I was good in sports. I was good in school, but I was marginalized. I was put with the gifted kids. You'd always get picked on. Luckily, I could defend myself. Dragons. I was always taking stuff apart. Doing the stuff, I know that's old school, yeah, whatever. Reading The Hobbit before it came out. I still read Harry Potter, doing all that stuff, but I could run fast and I could jump. My family didn't believe me. So I go through, you heard the story about the doctor deal, because of different barriers put up, because of where I grew up, there were people that tried to get me off the track to be a doctor, was told, you can't do it. The moment you get a bad grade, my freshman year, I had someone calling me trying to get me to switch. No shade to my friend John, I don't know if he left, no shade, but trying to get me to switch to business or economics, even though I wanted to do something that was meaningful. So there was that. Then, you have family challenges. One of the biggest challenges that happened, and And that's the thing is your education doesn't protect you from life. Dr. Mackey and I'm sure y'all are familiar, we've lived through hurricanes. You live through deaths in the family, you live through divorces. One of the most challenges was the pandemic, because I'm in front of 1 million to 2 million people a day, and I don't have any answers. We've never seen this before, and people were very passionate about it to the point that I got death threats. My life was threatened. Started running every day. I was 50 pounds lighter. I was sleeping 1 to 2 hours a day. It was rough, but it's dedication to craft. Seth Godin, Dr. Mackey introduced me to an author in a book called Tribes. My version of that is Jonathan Livingston Seagull. Richard Bach. I found that when I was 10 years old, and I read it almost every year, because the further you keep going, the more your tribe will follow you. I have a group of adults that read Harry Potter now, and that if I want to play Dungeons and Dragons with, I can. And as cool as he tries to be, Dr. Mackey is not Harry Potter, he's as nerdy as I am. So that kind of helped me when I got through to get through the pandemic. It's your peer group, it's the people, and then miraculously, randomly, following this genetics fad, I went 23andMe and Ancestry.com, found my dad. Thought I never had a dad growing up, thought it was just me. Turned out I'm a third generation doctor. Grandfather founded National Optometry Association, dad's a doctor. We have the same first name. We played the same position in college and football. We talk every day, and we're nerdy as I don't know what. He would be here, actually, if he knew it was gonna be all this. He and my stepmom sneak into conferences to hear me speak, which is kind of cool. So it's finding your tribe and just being committed and believing in yourself and believing in your honest peers. During the pandemic, Dr. Mackey and I decided we were gonna make our own pie because we don't have anybody else I wanted to talk to. So yeah, that's it. It's your peer group and your tribe.
One thing that, I agree with you, the pandemic actually brought up a lot of stress, and I think it taught us more about ourselves than anything else, right? So I think for me as a dietitian, I was working in many different settings. I don't work just in a clinic, I work doing many different things in the community, doing some telehealth. And I will say that something that helped me stay afloat was curiosity and consistency. Curiosity because I'm passionate about what I do. So with nutrition and food, even if it was just reading an article about dark chocolate, or how am I gonna cook this dark chocolate into this recipe, or let me use what I have here because I wanted to make a coffee rub. Like, there is a lot of science when you cook, actually. If anybody here likes to cook, like look into chemists, food chemists are very interesting people. But that curiosity really kept me alive. And it might not have anything to do with your profession or with what you want to achieve in life, but that little hobby that you like, that passion that you have for photography, coloring, running, marathon, like whatever it is, if you start applying that on a daily basis, like finding that niche that keeps you alive, that will help you throughout any obstacles, really. So curiosity, consistency is another thing that I preach a lot about, because to me, even talking about cardiovascular health, something that I tried to do with my family was being consistent with taking daily walks. And I have 2 teenagers, and it is hard to get them off their phone or off, the bed, out of the room. But that is something that throughout the pandemic, I really made an effort to explain to them why, and it's consistency. We have to do it daily because that's what's gonna help us to stay afloat. And that's what I preach to my clients. Don't be the weekend, jogger or the weekend marathon runner, because that's not gonna lead to much. But if every day you do a little bit of that little walk or whatever it is your goal, then you're gonna achieve something. So those 2 things, curiosity, consistency.
I'll be fast. I don't think I have much to add, but I think I always make sure that I'm having fun. right? And if there's something that I'm doing, even while I was doing my PhD, and sometimes you have those moments where nothing works. And you just breathe in and say, no, and making sure you're doing something that's meaningful to you. And Daryl already said that for him, meaningful means that it's gonna have an impact in the community or impact. And if there are bumps, finding people that can sort of help you out of that misery that you're going through. And it's the tribe concept, right? There's always that one friend or that one, there are times here at FIU in the beginning for me that it was tough, and I found a couple of professors that really helped me make sure that I was going in the right direction.
I think the part about really having a passion about the things that you're doing and having a vision for what that can be is really important, and reflecting on that consistently. So I think one thing that's really important to know that the path is never linear. Like you're going to wind, it's going to go up and down. You're going to have these times when you're really high and these times when you're really low. You have to know that those things are going to happen, but you have to be able to sit back and reflect on what journey you've gone on. So I think there are times when we can be in the lab, for instance, and an experiment doesn't go right, and you're like, well, is anything going to go right? And it goes on over and over again. But if you step back, you can recognize the progress that you've made and how much closer you're getting to that bigger picture vision. And so having that in mind is really important. I think it's also important to have that community of support around you. So really wherever you are, and I think that's reflective of everything that folks have said already, you have to have people around you, both peers and mentors, to help you to really put things in perspective. So when I go back to my time at Tulane University when I first entered, so I entered and was one of 2 Black men in the biomedical engineering department at the time, and very few within the College of Engineering. So being within that scenario and coming from a high school where that was just not the case, it was shocking and jarring. I was fortunate to find National Society of Black Engineers and folks around me to be peers to help me through those tougher times, and we're fortunate to find Dr. Mackey as our advisor and mentor to really provide some perspective on these are the things that are around you, and these are ways you can navigate this space. And so I think that's important in any space you go into, finding the folks who are your peers and finding mentors to help you to drive through, and being clear with them about what your vision is for yourself, because they can help to hold you accountable and help to provide some network and resources to get you through.
That question, right? And I don't know where it's coming from with you, but I get that question all across the country. And, that question is my life. When you look at the adversity that I've been through to get to where I am, it's just absolutely, people say that you're just not supposed to be there. And we live in the greatest country in the world where you can get up and create a better tomorrow for yourself. Somehow every Monday seems like people get up and don't want it. And I often ask myself why. And I speak to young people all across this country because I used to say, growing up, I thought my name was no. Can I go to your school? No. Can I go over there? No. You think I could be a doctor? No. You think I could do this? No. The pretty young women, I say, may I have your phone number? You know what they used to tell me? No. But what you gotta have is this thing called hope. Hope is that little voice in your head that whispers maybe when the whole world is screaming no. And there'll be people in your family that may tell you no. There'll be people in the program that you're in that may tell you no, but you got to find people around you that's gonna tell you yes, you can. And I wish in my life it was a lot of people, but it's never a lot of people. But I find that 1 or 2 and I would hang on to. And I know when I pick up the phone and call them, I know regardless of what I'm going through, they're gonna let me know that it's possible. I remember being in school when my mama died. I remember taking my qualifiers in. When my roommates came home, I'm laying on the floor in a fetal position with my backpack on. I cried myself to sleep because, you know, I've studied 6 months, 12 hours a day, and I failed, you know, and now all of this doubt coming in, because people told me you're not PhD material anyway. But I knew the people who to call and tell me, look, don't listen to those people. They don't want you there. You're supposed to be there. The STEM NOLA program that we started, me and my wife started this in our garage, and people said, what are you doing? It'll never work. And 125,000 people later, 15 million in revenue later, people got to say, what the, so young lady, every step along the way, people have told me no. And it wasn't my dream to get up every day and try to make them wrong. It's my dream to get up every day and make sure that I'm doing the things that I need to do to get to where I need to be. And it's the people. They say, if you want to know how you got to where you are now, look at the 5 people you hung out with 5 years ago. If you want to know where you're going to end up 5 years from now, look at the 5 people you're hanging out with right now. The greatest tragedy in life, and I tell high school kids this all the time, is 10 years from now, one day meeting a woman or man you could have been. You was the smartest one, you did this in high school, you was this, and somehow this other person is here, and you're not where you're supposed to be because you let what I call the boogeyman creep into your heart, creep into your soul. And a lot of times it comes from the people closest to you, like your family, like your friends, because misery loves company, and they know that if you go out and do this great thing, they're gonna have to look in a mirror and go, why I couldn't do it? And that's not about you, that's about them. Sometimes your success is a mirror for other people that make them have to decide and, you know, and look at themselves about what they did not do. So one, find people that believe in you. I mean, you gotta find those people. Stay away from the people that don't believe in you, all right? Because there are gonna be a lot of those. But make sure you get up every day and do the work necessary, such that no man or woman can put barriers in front of you that you can't come across.
That, I think, is it's time. Oh, no, okay. We're going to go to questions. That was awesome. Thank you. Please, yeah.
Whew. I have no idea. No, I mean, really, because they definitely can answer this. Because my thing is just fluid mechanics, and I mean, so usually when I'm talking to young people, I say I hate biology, I hate chemistry, I hate industrial engineering, I hate electrical engineering, I hate chemical engineering, I hate most of mechanical engineering. I mean, really. But my first degree is in mathematics because I love numbers. I told you I started college in remedial reading. So when I got to college, they said, what you gonna major in? I'm like, definitely won't be damn reading. You know what I mean? So I did the numbers, but soon as, like, when I got to my senior year of math, like, the numbers disappeared. You gotta read and write, like, proving stuff. So they said, you might wanna try engineering. And when they introduced me to fluid mechanics, I love to fish. If I wasn't here, I'd be fishing today. That's Daryl's fault. Because Fridays is Red Fish Friday, I go fishing. And I just love being out on the water. So water turned me on. So for me, whenever I did my cardiovascular research and stenosis and modeling, stenosis with collapsible tubes, I only looked at the mechanics of it. You know, I didn't look at the biology side, the stuff that I hate. I'm like, y'all handle that. You know, I'm gonna give you the forces, I'm gonna give you this, and you all make the diagnosis on it. But I said that to say that what we did here today, the reason why we do it the way we do it, is to let you know that you can participate in an apparatus without being on the medical side or without being on the biology side. There's a place for you in all of these different things.
So just to make sure, you want to know specifically about fluid mechanics and how that applies to cardiovascular. Okay. So I think there are a couple of different things to, specifically within the, looking at heart muscle in the research realm. So with heart muscle, the way it works is the heart fills and then it contracts to push blood out. And so that happens differently at the macro scale, so what we're seeing right now versus the micro scale. So in the space where cells live. And so understanding how we can manipulate the things that we see with fluid at the micro scale may help us to drive cells to do things that we can't do yet at the macro scale. So understanding that, and you really do that through fluid mechanics, through modeling, through flow experiments, through Bernoulli's principle. You do that to really understand, how cells can be manipulated in different ways. And I think that can give us some clues to how we can work towards regenerating tissues. I also think that the way we typically culture tissues, so culturing a tissue and creating a tissue model can be a model of the system itself. The way we typically do that is statically, so it's just held in place and not necessarily with fluid flow. And so there's some researchers here, so Sharon Amaslami here does some bioreactor work where we see flow, and being able to mimic that flow and see how cells respond to it can give us some interesting, I think, answers to how we can better get towards regenerating tissue. Yeah.
I just want to sort of add a little bit that you're never going to solve anything related to anything just by one approach, right? So as much as you hate biology, chemistry, whatever, and you said it, you've always collaborated, right? So there is a possible contribution of fluid mechanics to solving whatever cardiovascular problem, but you're good. And it's always a good idea for you to have a general understanding of everything. And Darrow saying you need, right, to understand how the cells respond to it. So I just wanted to put that everything has to be sort of interdisciplinary.
I just want to start, first of all, I'm not going to let him sit up here. You have to find someone to hold you accountable. I'm not going to let him sit up here and let y'all think that he started off in remedial reading and da-da-da-da. He did, but he didn't. He's not telling you the whole story. He graduated with the top honors at the top of his class in college, Phi Beta Sigma and whatever the other, did I see that? That's what I'm saying, Phi Beta Kappa, and what was the other one? Tau Beta Pi, which are the highest honors you can get in science, in math, and in the arts, the highest. Wait. Always, always, always give flowers to your tribe and surround yourself with a tribe of people that are smarter than you. Smarter than you. Always get in the room where you're not the smartest person in the room. I don't know if you noticed this, but I don't like biology, or this is not my area, I'm a geneticist, and da-da-da-da-da. But if I sit up here and start asking, listen, man, I'm trying to figure out how to explain to an 8-year-old about how fluid and genetics and diet to work in the body. How can I explain that question that you asked in terms of fluid? I guarantee you we'll get a simple explanation about, because we have the smart people in the room, explaining how it's just fluid in the body. There's a different viscosity. There's different pressures based on the diameters of the tubes, of the blood vessels, the structure of the valves, I didn't know there were melanocytes in valves. Holy smokes, in that then. I'd have scratched all my hair had I not known that. But that's the point, though. Again, I grew up in a house with my grandmother who had a high school education, and her answer was always, well, baby, I don't know. And you just sit around and you wait on the butt, and she gives you everything that you want. So don't be afraid to ask, and look to, a lot of times you're looking for the answers, and they're right there beside you or in front of you.
I know we have a lot of folks who have to get back home soon, so with that, we're going to start wrapping up. Before we go, I want to give each of our panelists a gift from FIU. I think that was fantastic, and I think that ending on collaboration is really important too. And I think especially with something like, you look at a panel like this, you see the importance of prevention, of treatment, of research, of engagement, how important all of this will be to solve these huge problems we have in cardiovascular medicine. So I thank all of you for attending today, and I hope to see a lot of you back next year, hopefully same place, similar time, so look out for the announcement.